The function s is defined by s of x is equal to x squared minus 6, where x is less than 0, and 10 minus x, where x is greater than or equal to 0. And we need to sketch that. So let's sketch the quadratic first of all, x squared minus 6. So when x is 0, y is minus 6. When x is minus 1, we get minus 1 squared, which is 1, minus 6, so that gives me minus 5. When x is minus 2, we get minus 2 squared, which is 4. Minus 6 is minus 2. When x is minus 3, we get minus 3 squared, which is 9. Take away the 6 is 3, and so on. So my quadratic is going to look something like this. It's just a sketch. And I only need to draw the negative part of the graph here because it's only defined for x is less than 0. Another thing I'm actually going to do, because x can't equal 0, y can't equal minus 6. So I'm just going to draw a little hollow circle there when x is 0 to signify that. 10 minus x, well, when x is 0, y is 10. X can equal 0, so y can equal 10. So I'm drawing a solid circle there. And then we've got a gradient of minus 1, so that's going to look something like this. Part B. Find the values of a such that s of a is equal to 43. So when could this function equal 43? Well, let's check. Let's do the quadratic first. So x squared minus 6 is equal to 43. Let's see if that works. Except it should be a here rather than x. Let me change that. Add the 6 to both sides and square root, and I find that a is either 7 or minus 7. But I'm going to cross out the 7 because I know that this quadratic here is only defined for negative values for when x is less than 0. So the minus 7 is the only valid solution from the quadratic. The linear graph, let's have a think about that one. So 10 minus x, or a in this case, would have to equal 43. Subtract the 10 from both sides, so a would have to equal minus 33. But the linear graph, the 10 minus x, is not valid for negative values, it's only valid for positive values. So I'm also going to ignore that solution as well. So minus 7 is the only valid solution for part B. Part C says to solve s of x is equal to x. So let me draw the graph of y equals x onto my graph, and then I can see if and where that s of x intersects with x. So y equals x looks something like this. So it looks like they intersect in 2 places, and I can probably read those coordinates off, but let's just solve it algebraically to be super careful in case my sketch is not quite accurate. So down here, my quadratic is equal to x. So let's take the x squared minus 6. When does that equal x? Subtract the x from both sides. And factorise. And we see that either x is 3 or x is minus 2. The 3 solution is not valid because this quadratic is only valid for negative values. The minus 2 is valid, so that is one solution of this equation. It could also be over here though as well. So that's where our 10 minus x is equal to x. So 10 is equal to 2x, so x is 5. And yes, that straight line is valid for when x is 5, because that's greater than 0. So two solutions, -2 and 5.